So today we discussed about in atomic structure and elementary quantum mechanics of atoms. So in the chapter, mainly we discussed about quantum theory of radiation, that is the black body radiation, and photoelectric effect. Next one is the what is the photoelectric effect. Next one is Compton effect, wave mechanical concept of the atom, de Broglie relationship, and Heisenberg uncertainty principle. Next one is the eigenvalues, Schrodinger wave equation. These eigenvalues and eigenfunctions. These are the main topics in your syllabus. So now let us go to what is the atom, what is the atomic structure. First of all, we discussed about so you see slide clearly, everything in slide, but you have to see the slide and I'm going to explain every one. So in 1900, Max Planck studied the spectral lines obtained from hot body radiations at different temperatures and observed that the light radiation were produced discontinuously by the molecules of the hot body. Thus, according to Planck, a hot body radiates energy not in continuous waves, but in small units of waves. The unit wave or pulse of energy is called quantum. That is the Planck's radiation theory. What that is the Planck's radiation theory. What is the Planck's radiation theory? So you take any hot body. In that hot body, you pass the light some frequency. Then hot body absorbs energy and maximum energy and heated. After that, some stabilizing, it emits the some wavelength light again. So the energy of the light called quantum that is the hot body radiation. This hot body is made up of by, that is a conical flask. In conical flask, inside of the wall coated with platinum, outside of the wall coated with carbon, that is the black body. It having the narrow tube hole opening, that is the narrow opening. If from the opening you have to pass the light with some frequency, then what happen? The metal, that is platinum coated plate, observe the light. After some time, the total body is get much more energy and stabilized. After that, it emits the light with some frequency. The frequency of light energy having some power, that power is called quantum. That is Planck's radiation, that is called Planck's radiation. Next, the essential features of the above proposed quantum theory of radiation may be summarized in the following points. What are the points? When a hot body or an atom or a molecule emits, absorbs radiation energy, it does so in separate units of waves called quanta or photons. Thus, light radiation emitted from excited body or atom consists of a stream of photons and hot as continuous waves. You see in the slide clearly, the waves continuously passed. The waves are continuously passed. Below the slide, that emitting light having some quanta, that is the individual quarter photons. So the energy of a quantum or photon is given by the relation E is equal to h nu, that is C is equal to h nu, E is equal to hc by lambda, that is the main equation, where V is the frequency of emitted radiation, h is Planck's constant, c is velocity of radiation, and lambda is wavelength of radiation. The magnitude of a quantum or photon of energy is directly proportional to the frequency of the radiation's energy, or is inversely proportional to its wavelength. An atom or a molecule can emit or absorb either one quantum of energy h nu or any whole number, that is important, if it absorbs the energy that is in whole number, like h nu, 2h nu, 3h nu, but not in fractions, that is 1.5, 2.5, 3.5. That is not correct. Always the photon energy in numerically with whole number, that is equal to h nu, 2h nu, 3h nu, 4h nu, like this. Okay. Next one is the photoelectric effect. What is the photoelectric effect? When a beam of light suitable wavelength or frequency is allowed to fall on the surface of a metal, the electrons are ejected from the surface of the metal. This phenomenon of emission of electron is known as photoelectric effect. What is the photoelectric effect? When I repeat it once again, when a beam of light of suitable wavelength or frequency is allowed to fall on the surface of a metal, the electrons are ejected from the surface of the metal. This phenomenon of emission of electrons is known as photoelectric effect, or photoelectric emission. And the emitted electrons are known as photoelectrons, which are in no way different from all other electrons. That is important. So, some laws of photoelectric emissions. What are the laws of photoelectric emission? Photoelectric effect is more common in metals having low ionization energy, that is alkali metals. That is important. What is the alkali metal? Photoelectric effect is a common effect in metals because of the metals having the low ionization energy. That means they release electrons easily. Second one, only radiations have a certain critical or limiting minimum value of frequency can eject electron. Only radiations having a certain critical or limiting minimum value of frequency can eject electrons. A radiation having frequency smaller than threshold frequency, that is important. Threshold frequency. A radiation having frequency smaller than threshold frequency cannot eject the electrons. No matter how high is its intensity and for how long it falls on the metal surface, the magnitude of threshold frequency is different for different metals. Third one, An increase in the intensity of the light of a given frequency increases the number of electrons emitted per second for the surface. Next, the kinetic energy of the photoelectrons increases with the increases in the magnitude of the frequency of the incident light, and hence a plot between the kinetic energy of the photoelectrons and the frequency of the incident radiation will be a straight line. You see the slide in clearly, but that is the straight line. What is a straight line? The kinetic energy of the photoelectrons increases with the increase in the magnitude of the frequency. Of the incident light, and hence a plot between the kinetic energy of the photoelectrons and frequency of the incident radiation will be a straight line. You see the slide clearly. The graph is given. What is the graph in between? Frequency of incident light. Next one is the explanation of photoelectric effect by Planck's quantum theory, where a photon of light of frequency falls on a metal, some of the energy associated with the photon h nu is used to separate the electron from the surface, and the remaining energy is impaired to the ejected electrons to give it certain velocity. Say u. Due to this velocity, the ejected electron gains kinetic energy equal to half mu square. The part of energy used to separate the electron from the metal surface is equal to binding energy of these electrons, but commonly known as threshold energy or work function mathematically. What is the photoelectric effect by Planck's quantum theory? When a photon of light of frequency V falls on a metal, some of the energy associated with the photon h nu is used to separate the electron from the surface, and the remaining energy is imparted to the ejected electron to give it certain velocity, say u. Due to this velocity, the ejected electron gains kinetic energy equal to half mu square. The part of energy of the photon, but commonly known as threshold energy or work function. The mathematical equation is threshold energy is equal to h nu naught. The above discussion reveals that h nu is equal to h nu naught plus half mu square, where h nu is the energy of the incident photon. H nu naught is the minimum energy for an electron to escape from the metal. It constant for a particular solid and in designed it as W, and half mu square is the kinetic energy of the photoelectron. H nu is equal to plus, that is h nu is equal to W. W means here work. W plus half mu square. Half mu square is equal to h nu minus W. This is the equation for a straight line that was experimentally obtained in equation Planck's constant. The value of h thus found came to be the sum as was given by Planck himself. So this is the Planck's quantum theory. What is the mathematical equation? Of mu square is equal to h nu by W, or h nu is equal to W plus half mu square. H nu is equal to W plus half me square. That is the uh, Planck's quantum theory. Next one is the Compton effect. What is the Compton effect? What is the Compton effect? Uh, in 1923, Compton provided another proof of the quantum theory or the photon theory. He found that when X-ray of high energy are allowed to fall on solid matter like carbon block or some other light element, an electron is ejected from the carbon block and X-rays are scattered from their original path and possesses longer wavelength than the incident X-rays. Compton argued that ejection of electron and scattering of X-ray is possible only when X-rays consist of particles, photon, and X-rays would be a continuous wave. Neither electron should be ejected nor incident X-ray should be scattered. It has been found that the scattered X-rays have longer wavelength than the incident X-rays. This phenomenon is which there is a change in wavelength of the scattered X-rays is called Compton effect. The angle through which the incident X-rays are deflected from their original paths is known as angle of scattered and is denoted by theta. The theta is the angle between the incident and the scattered X-rays. By assuming photon electron collisions to be perfectly elastic, Compton found that the shift in wavelength d lambda was given by the expression d lambda is equal to 2 lambda by mc sine square theta by 2, where m is the mass of an electron, c is the velocity of light, and theta is the angle of scattering. The expression shows that d lambda is independent of the nature of the substance and wavelength of the incident radiation. Here you observe in the slide clearly. Here see in the slide photon, that is incident X-ray on a substance. Then what happen, the substance get some energy and remaining energy is passed away with scattered X-rays, that is wavelength lambda dash. So whenever X-rays are passed on metal, the electron are emitted. That electron is called scattered electron. Energy is equal to mc square, momentum is mv. Electron at rest energy m naught c square, momentum is equal to m naught x naught is equal to 0. So photon before the scattering, the photon energy h nu by lambda, momentum is h by lambda. So this is the uh, explanation of Compton effect. What is the theme of the main Compton effect is the X-ray pass on metal surface. Then what happen? The metal absorbs the energy. That energy utilized for the uh, emptying of electron. The remaining energy is passed away from the body, that is scattered X-ray light with minimum wavelength, that is lambda dash. In between these two angle is called theta. So incident X-rays wavelength is smaller than scattered X-rays wavelength. That is important in Compton effect. So This is Compton effect. Next one is the what is the wave mechanical concept of the atom. Bohr model is discussed earlier has some inherent defects, two of which are I. The simultaneous assignment of an exact position and definite momentum to a given electron, which is uh, contradictory to the Heisenberg uncertainty principle of quantum of angular momentum, for which no justification was made by Bohr. A more satisfactory picture of atomic structure like radiations emerged as a result of deep solution. So today we discussed about only three topics. What are they? Black body radiation. First one is that is E is equal to h nu by E is equal to h c by lambda, because of here c is equal to h nu. So second one is the photoelectric effect. Photoelectric effect. Next one is this photoelectric effect is explained by Planck's. What is the Planck's equation? H nu is equal to W plus half mu square, or half mu square is equal to H nu minus W. That is the Planck's theory. Next one is the Compton effect. What is the Compton effect? What is the mathematical equation for the Compton effect? D lambda is equal to 2 lambda by mc sine square theta by 2 sine square theta by 2. That is the mathematical equation for the Compton effect. Next one is the what is the main mechanical concept of the atom. Mechanical concept of the atom is explained by de Broglie equation and Heisenberg uncertainty principle and eigenvalue through eigenvalues. So these are the later we discussed in next class. So clearly put slide everything. So you have to follow the